Alrighty, let's check homework. This is the homework for the last lesson of Chapter 1, 1.2.2. And the M&Ms for this particular homework have to do with strategies for solving proportions. So once you realize that a problem that is presented is proportional in nature, then there are some strategies that you can use to solve those problems. And one thing to keep in mind about proportions is, proportions are basically when you have two ratios that are equal to each other. So you'll notice that every time you've got equivalent fractions, the cross products are always going to be equal to each other. So 6 times 3 is 18, and 9 times 2 is 18. That proves that this is actually a true proportion. This ratio is equal to that ratio. Same thing applies here. If I take 5 times 70, that is 350. And if I take 7 times 50, that is also 350. So with that in mind, when we know that the cross products will be equal to each other, then we can solve for a missing piece if we've got 3 parts of the 4 parts. So 9 over 2 is equivalent to what over 16? So there isn't just one way to solve these. You saw this last year, how sometimes the problem sets up nicely for a giant 1, where you look at the known quantities in the denominator, 2 and 16, and what do you multiply times 2 to give you 16 for an answer? That is 8. So we'll also multiply the 9 times 8, and we will get 72 over 16. Therefore, x has to be equal to 72 for this particular problem. The undoing division was probably my least favorite process to use here, and it's based on this. We know, like, if you solve the problem x plus 2 is equal to 5, to figure out what x is, you would undo the addition, right? What was x before we added the 2? So we would take the 2 away from the 5, and that would prove that x was equal to 3. Well, same thing is happening here. If you take x divided by 16, you get 9 over 2. 9 halves is the same as what, 4 1/2? So we have to figure out what that number was, and one of the steps along the way would be, well, let's get rid of this division problem. If I multiply the left side times 16, it'll cancel out the division of 16, effectively undoing the division by choosing the inverse operation. But you can't just multiply the left side of the equation times 16. You also have to multiply the right side to keep everything balanced. So on the right side, you could do some cross-canceling, but what they've shown here is just multiplying 9 times 16 is 144, and 2 times 1 is 2. So then you complete that process to get the same exact answer that we got here, x is equal to 72. Not my favorite approach. I like the giant 1, and I also like the cross multiplication. And cross multiplication is essentially fraction busters. When you multiply straight across, what you're essentially doing is multiplying the left side times 2 over 2, and the right side times 16 over 16, which gives you a common denominator. So all you really have to do is compare what's in the numerator. So that's essentially what's happening here, but you cross multiply, you get 2x equals 144, and then at the end, divide each side by 2, and you get the same answer. So I'm a big fan of cross multiplication. I'm a big fan of the giant 1. Most students agree with that. If it's an easy process, you can use a giant 1. If it's at all complicated, go to the cross multiplication. All right, speaking of which, in situations like this, let me actually block some of the lower problems out, change to my favorite. Nice. Okay, so you can cross multiply if you wanted to. You could say 36 times x is equal to 720, and then divide 720 by 36, and you would get your answer. Some students will look at this and say, I want to do a giant 1, and I know I can simplify this fraction. So it turns out you could say x over 24, hold on for a second, need a thinner pen. X over 24 can't be simplified because you don't know the value for x, but this can. If you divide the top and bottom by 6, you get 5 over 6. And now you can clearly see, hey, 6 times 4 is 24, so 5 times 4 will give me 20. So that's a good way of doing it, or you can just cross multiply. here, you don't really have a choice. You can't simplify it, and trying to find a giant 1 for whatever you multiply times 3 to give you 7 is going to be somewhat complicated. So I would absolutely cross multiply here and say 7x is equal to 15. And now you divide each side by 7, and x is whatever 15 divided by 7 is, which turns out to be 2 1/7. Here, if Joan reads 75 pages in 4 hours, how long will it take to read 250? Well, we know this is proportional because number one, I guess we don't know that she's reading at a constant rate of speed, but it does kind of imply that. But more importantly, the fact that if you spent no time reading, you wouldn't read any pages. So we'll write this ratio, 75 over 4 is equal to 250 over x. And I'm wondering what is 250 divided by 75? Okay, we can still use this as long as you keep it in the calculator and then multiply this immediately times the 4. You get an answer of 13 1/3, right? Or 13.3 repeated. Some of you may have chosen to write it as 13 hours and 20 minutes, because that's a third of an hour, right? 60 minutes in an hour. So you could have written it in a few different ways and it would have been correct. I don't know what that 3 is there. Mr. Wright was making a table to figure out how much it would cost to send a certain number of regular letters through the mail. Use proportional reasoning to complete this process, complete the table. All right, so I'm going to use this one right there. By using that, I'm going to be able to figure out my unit rate by dividing $4.50 by 10. And so once I know that 1 is $1 is 45 cents per stamp, then 2 would be 90 cents, and so on and so forth. So you could start off with the whole $4.50 for 10, and then plug in the rest of the information like 675 over x and use your proportional reasoning. But I think most students are pretty good at figuring out the unit rate. Y is equal to be 45 cents per letter or per stamp. And so if you know this number, you plug it in for y and divide by 45 cents. If you know this number, you plug it in for x and you do the multiplication. If anyone wants me to work any of those out, just let me know. I'll take care of that for you. All right, what do we have here? A histogram and a frequency table. Kelly asked some students, some of her classmates, how many hours of sleep they get on school nights. Here are the results. It would be really nice if these numbers were in order from least to greatest, but they don't necessarily have to be for histogram. What I'm noticing is this. I'm gonna break these into hour intervals. So anything that's in the 6-hour range, I'm gonna highlight in yellow. Anything that's in the 7-hour range, I'm gonna highlight in green. Anything that's in the 8-hour range, I'm gonna highlight in blue. Anything that's in the 9-hour range, I'm gonna, oh, hold on for a second. I missed this guy. Someone's at my door. I'm gonna go answer it. Hold on for a moment. Okay, sorry about that little interruption, but I'm sure it didn't affect your day at all. All right, so the 9s, we're highlighting the 9s, and I'll just leave the 10 open. So when we're going to break these into intervals, it looks like they want us to have these in intervals of hours here, right? Not half hours because of the way that this graph is made. So these are what we refer to as bin widths. And so how many students fell in the 6-hour range? Well, that was 2 students, right? So we would put that one right here. Oh, I'm not going to highlight that. That looks terrible. So we would make this bar go up 2. Notice how nobody was less than 6 hours, so those are all blank. How many people were in the 7-hour range? 1, 2. So there's 2 of them there. So there's 2. How many were in the 8-hour range? That was 1, 2, 3, 4, 5, 6 of them. So we make sure that goes up, that bar goes up to the 6, and then we had 4 in the 9 range. There's the 4, and only 1 in the 10-hour range. Who in the world is getting 10 hours of sleep? That's incredible. All right, so that's the correlation. You do the frequency table to determine how many fit into each category or each interval. and then you go ahead and create the histogram. And since our x-axis of the histogram is referencing a number, right, this is numerical data, we're not going to have any gaps in any of those bars, as opposed to a bar graph where you had categorical data at the bottom. So you would just do separate bars for each one of the categories, like your favorite ice cream or whatever. All right, here is a chance for us to practice the 5D process. I'm going to start off by reading through the problem, and then I'm going to write out the essential information. So we're going to start with describe. Todd is 5 years older than Jamal. The sum of their ages is 64. How old are each of them? All right, so we know we've got Todd, and we've got Jamal, and we've got the total sum of ages. And they did give us that information, so I'm going to write down 64. They did not tell us how old Todd or Jamal are. However, Todd is older than Jamal. So if Jamal was like 10, he would be 20. If Jamal was 30, he would be 40. So whatever Jamal's age is, 10 more than that will be Todd's age. So we could go through and do a guess and check like I was just doing. If Jamal is 30, he's 40, but that's supposed to be 64. That's 70. That's too much. And so you can do it that way, or we could set up the equation, right? So we know that we have two x's there, plus 10 is going to be equal to 64, right? X plus 10 plus x is equal to 64. The total sum of this guy's age and this guy's age is 64. So when we take away the 10 from each side, remember removing balanced sets, we get 2x is equal to 54. And then when I divide 54 by 2, that is going to give me the value for x, which is 27. So this is our describe, this is our define. We defined our variables. This is the do portion. I chose to set it up as an equation. Now I need to decide if this is correct. If Jamal is, let me do this in green. If Jamal is 27, then he has to be 27 plus 10, which is 37. And is 27 plus 37 equal to 64? Turns out that it is. So that was the decide. And now here we have our declare. Now it is not important that you label each one of those sections for the 5Ds. But it is important that you go through the process and do this work. This is all the work that I've shown. I've declared my answer, but anybody who looks at this work will be able to figure out from the problem how you organized everything, how you set up the equation, you solved the equation, and then you check to make sure the answer was right and declared your answer. That's good problem solving. All right, and now the last problem of our homework for this unit is usually a checkpoint problem. And the checkpoint, as you remember from 7th grade, no doubt, is telling you that at this point in your mathematical career, 8th graders should be experts at adding, subtracting, multiplying, and dividing rational numbers that are both positives and negatives, right? Here you got two negative fractions. You need a common denominator. You need to know the rule for adding two negatives together. Here you got decimal numbers. You got to remember the rule for lining up decimals and so on and so forth. So if you're making mistakes on these problems, it really is up to you to make sure that you get in some extra practice. Now, these kinds of problems show up in our homework all year long. There's no lack of practice of these types of problems. They'll pop up once every week or every couple of weeks just to give you an opportunity to practice it. But there is a place you can go in the online book where you can get extra practice if you know that this is a concept that you're struggling with, but you're really expected to have this mastered by the time you go to high school. So here over in our menu, you go down to reference, you hit checkpoints, and the checkpoint problems for each chapter are shown. So you can go to checkpoint problems 1, and lo and behold, there are all the answers. But more importantly, dude, come on. More importantly is they show you examples of how to solve these problems, and then they give you a series of problems for you to work on. And here you've got 32 different types of problems that involve adding, subtracting, multiplying, or dividing positive and negative rational numbers. And you can check to see how well you're doing. So if you do if you go back and review the concepts and then you do the first 10 and you want to check your answers and you're getting them all right, don't bother doing the rest of them. You got it. If you got 10 out of 10 correct, you understand and you don't need to put in the extra time. But if you're still making mistakes, then maybe do the next 10 and go to 20 and check those answers. But this is, you taking on personal responsibility for your learning. I can teach you how to do these concepts. I can provide you with some problems to do. But if you're struggling and it's taking you a little bit longer to learn, say, this concept than it was to learn how to combine like terms in algebra, then you take it upon yourself to get that extra practice because it really is in your best interest. You're going to find high school is much easier if you put in the time now to make sure you understand some of these basics. Okay? All right, 16 minutes, not too bad. More than the 10 that I normally like, but there was a lot going on with this homework. So, all right, so we are going to get into study mode with study guides, and we're going to start preparing for the Chapter 1 test soon. So why don't you head to that work. Take care. Bye. Hey,